Okay, here we are again, trying to finish up these square roots. Well, it is so much to talk about, and square roots are so important. You ever wonder how long it takes to reach the water when you step off a diving board? Will it take 5 seconds, 2 seconds, maybe 1 second? But actually, you can find your answer with operations with square roots. So it's a good thing for us to practice and learn the format. Okay, saying that, let's see, can we talk about it a little bit? Now, a square root symbol is called a radical symbol. And an expression containing a radical symbol is called a radical expression. The value underneath this radical symbol is called the radicand. So, in plain words, if I took the square root of 16, then of course this is my radical symbol, and of course 16 is my radicand. That's pretty much all that is in a nutshell. Okay, it's so much. We can use distributive property to combine like terms, and we probably need to revisit like terms, but we know what like terms are. They are terms. If we're adding 5 plus 5, 5 is a term, 5 is a term, and we're literally just we're adding them because they are constants. If we're adding 2x and 4x, we're adding them because they are like terms, meaning they both have a coefficient. And even if x was not with a coefficient, the coefficient is understood to be 1, but the actual degree, the exponent itself for 2x and 4x is 1, x to the first power. So they are like terms. We need to keep that same analogy when we're dealing with adding and subtracting square roots. Let's take an example. So here, example A, I want to add, or see if I can add, 2 times the square root of 10 plus 5 times the square root of 10. Well, we know that the radicands are the same. Now, if they are the same, then they are like terms. Okay, so the only thing we want to do is combine the like terms. And what I mean by that, we want to combine the numbers in front of the radical. Again, if it's understood that if there's no number in front, that number is 1. But here, the numbers in front of my radical is 2 plus 5. So I would have 2, the square root of 10, plus 5, the square root of 10, is equal to 2 plus 5, the square root of 10. Okay, adding it up, I will get 2 plus 5 is 7, the square root of 10. Now, of course, this is simply called simplifying. So this is simplifying here. We didn't solve it or evaluate it. We just simply simplified. We know that we could go on further and call this 3.1 times 7 and get a different figure. But here, in this exercise, we're just simply simplifying. Okay, so let's take a look at another example. Example B tells us the square root of 2 plus 5, and I want that not to look like an 8. 5, the square root of 3 minus 4, the square root of 2. Now, as we analyze what we've just put on paper, we see that we have two actually radicals with the same radicand and one that's not. So we want to use what's called commutative property to put those in a way where we can work them together. So here I want to say the square root of 2 plus 5 times the square root of 3 minus 4 times the square root of 2 is going to equal to the square root of 2 minus 4 times the square root of 2 plus 5 times the square root of 3. And again, I use commutative property to switch here and here. Okay? So that will give me, then again, that's called commutative property. Okay, so let's see, can we continue on with this one? So now what we can do is, because we have the like terms, we can go on and separate and add. Now, one thing I want you to understand here is we need to know that this is a 1. So I'm going to put a 1 here, square root of 2 minus 4 times the square root of 2 plus 5 times the square root of 3. And the only thing I'm asking you to do is just think and understand that, think of the square root of 2 is the same as 1 times the square root of 2. It's just like if we were using an exponent and the exponent said x is really 1x. Okay, so from here we will take a look at combining our like terms, which is 1 minus 4. So that would give us, in parentheses, 1 minus 4 times the square root of 2. Our radicand is square root of 2, that's common, plus 5 times the square root of 3. And the only thing we're doing here is combining like terms. Okay. Excuse me. Well, I want you to pay close attention here, because here we have the rules of integers. So this is the same as 1 plus a negative 4. Okay, times times the square root of 2 plus 5 times the square root of 3. And this is the integer rule. Now, what we do according to the integer rule is, when we have terms with different signs, we simply just subtract the smallest absolute value from the largest absolute value, and that's going to give us 3, and we use the sign of the largest absolute value. So that's a negative 3 square root of 2 plus 5 square root of 3. Now again here, this is just simplified. We can go on and evaluate the expression by finding estimating the square root of 2 and estimating the square root of 3, but the problem simply asks us to simplify, and simplify is where we are. Okay.